Welcome back, everyone. Let's dive right into this explainer and decode exactly what the examiners are looking for when you sit down for your Cambridge papers. Today, we are adopting what I like to call the weightlifter strategy for your computer science exams. Think about how a professional weightlifter operates. It's all about maximum effort in short, highly concentrated, explosive bursts. That is exactly how you need to approach the high-mark, complex questions in your papers. You can't just casually lift the weight. You have to use proper form and targeted power. Today, we are tackling an absolute monster of a topic, parameters and procedures, specifically passing by reference for the Cambridge AS and A-Level 9618 syllabus. We'll also be drawing on some classic pitfalls seen in past papers like the infamous Code 9713 series. Now, to really illustrate the challenge we face with this topic, I want to introduce you to two archetypal students I see all the time in my classes. First, we have Alex. Now, Alex is a walking textbook. Alex overloads every single answer with raw computer science facts, memory addresses, and complex pointer definitions, but offers absolutely no analysis of the specific code provided in the question. Then we have Sam. Sam is incredibly smart, grasps the concepts quickly, but always rushes. Sam looks at a complex pseudocode block, panics under the time pressure, completely misses the critical command word requirements, and starts writing a brilliant solution to a completely different problem. Both of these students, Alex the fact dumper and Sam the rusher, leave massive amounts of marks on the table. In this explainer, we are going to look at their flawed approaches, understand exactly why the examiner's red pen comes out, and build an airtight strategy to ensure you never make those same mistakes.
This quote right here comes directly from a senior examiner, and it brilliantly illustrates why we literally cannot afford to ignore this core topic. It appears in every single examination series, no exceptions. But why? Why are examiners so obsessed with this? Because passing parameters by reference is the ultimate undeniable test of whether you actually understand how a computer manages state and memory at a fundamental level. When you pass a parameter by value, you are essentially just making a safe, isolated little photocopy of a variable. You hand the procedure a copy, it plays with it, and the original remains perfectly intact. But when you pass by reference, it is a whole different ballgame. You are handing over the actual keys to the physical memory location. You are allowing a procedure to fundamentally, permanently alter the original data stored in that address. Examiners absolutely love testing this because it immediately separates the students who just memorize syntax from the students who truly understand computational architecture. It shows who knows the difference between manipulating a temporary stack value and changing a permanent heap or global state. If you want those top A-star grades, you have to prove without a doubt that you can safely and logically navigate this concept.
So we have to ask ourselves, why does such a predictable, guaranteed topic continue to trip up so many incredibly well-prepared students year after year? Think back to our two students, Alex and Sam. When presented with a complex, multi-step trace table involving parameters being passed by reference back and forth through loops, Alex tries to just mental math the whole thing and write down the final output, completely ignoring the method. And when that final output is inevitably wrong because of one tiny microscopic arithmetic error on row 3, Alex scores a 0. 0 marks for a page of work. Sam, on the other hand, sees the command word evaluate next to a pass by reference scenario and instead just writes a basic textbook description of what passing by reference means, completely ignoring the specific banking or inventory scenario in the question paper. High-mark questions require that explosive weightlifter power and precision we talked about. You absolutely cannot just coast on basic definitions. You have to demonstrate a rigorous, multi-step logical progression.
To solve this and get you those maximum marks, here is our agenda for today. 1. The Passing Reference Challenge. 2. Core Theoretical Principles. 3. The Technical Methodology. And 4. Examiner Warnings and Insights. Let's get to work.
Section 1. The Passing Reference Challenge.
So, the absolutely crucial point here is that you aren't just regurgitating facts, you are actively interpreting data and proving your underlying logic. When you look at an exam question involving memory addresses or binary representations of data being passed into a procedure, you must extract the relevant information first. But how do we actually draw these evidence-based conclusions? It all comes down to decoding the command words. The command words are your blueprint. If a question specifically says trace, it wants a step-by-step state change shown in a table. If it says explain, it wants the how and the why, not just a list of features. When Sam rushes and treats an explain question like an identify question, the examiner literally has no choice but to cap the marks at the lowest band. You must calibrate your explosive effort to the exact command word used. Now, before we continue and reveal exactly how to structure these answers, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. We are putting out top-tier strategy content like this all the time, and you don't want to miss it.
Let's move on to Section 2, Core Theoretical Principles.
To succeed here, you must clearly establish the causal relationships within your code rather than just writing out vague, floating concepts. To do this, I want to introduce you to the absolute gold standard for structuring your written computer science answers, the PEAL framework. This is how top students construct their answers, and it stands for point, evidence, explanation, and link. Let's look at how Alex and Sam could transform their grades using this. First, you make your point. The variable player score is passed by reference. Boom, clear and direct. Then you provide evidence extracted directly from the source code provided, as explicitly indicated by the BYRF keyword in the procedure header on line 12. Next, you offer your explanation, showing off your technical knowledge. This means the actual memory address of player score is passed into the procedure, so any arithmetic changes made within the local scope will directly overwrite the original global variable. Finally, you link it back to the specific context of the question to secure the final mark. Therefore, after the procedure executes, the global player score will have increased by the bonus amount. That is how you build an undeniable theoretical architecture in your exam. It's structural, it's logical, and it forces the examiner to give you every single mark.
Now, what is really fascinating about the grading rubrics is that examiners explicitly, purposefully reward students who connect passing by reference to other areas of the computer science syllabus. The best candidates realize early on that computer science isn't a set of isolated islands. Whether you are studying foundational syllabus codes like 0417, 0478, 0983, 0984, or 2210, those foundational concepts connect directly to the advanced 9618 course we are tackling today. Passing by reference heavily links to data structures, operating system memory management, and even cybersecurity. For instance, if you can clearly explain how passing a massive, multi-dimensional array by reference saves critical stack memory compared to passing it by value, you are suddenly demonstrating an advanced, holistic understanding of computer systems. You are showing the examiner that you see the entire chessboard, not just one piece.
Top-scoring candidates don't just write code blindly. They demonstrate higher-order evaluative thinking by analyzing trade-offs and justifying their programming choices. If a multi-part question asks whether a specific parameter should be passed by reference or by value, don't just guess, pick one, and move on. Evaluate it. Consider the real-world trade-offs. Passing by reference is highly memory efficient, but it's fundamentally risky because of unintended side effects. What if a bug in the procedure corrupts your core data? Conversely, passing by value is incredibly safe because of data isolation, but it's highly memory-intensive for large data structures. Acknowledge these limitations and then justify your final decision with hard evidence from the scenario. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
All right, let's jump into Section 3, the technical methodology.
This 5-step standardized sequence you see here is your ultimate playbook for tackling complex algorithmic problems systematically. I call this our computer science success blueprint. Think back to our student Alex, who dumps facts without context. If Alex used this blueprint, the entire game would change. Step 1 forces you to actually read and deconstruct the command word. Is it evaluate, explain, or trace? Step 2 forces you to extract only the relevant data from the pseudocode, ignoring the distractors. Step 3 is where you lock in and apply your PEAL framework. Step 4 is absolutely crucial, executing your analysis with crystal clear working and correct notation. And Step 5 is where you verify your edge cases before moving on. If you apply this framework, you can practically see your mark potential, progress bar shooting from 20% right up to 100%. It turns chaos into a systematic, repeatable process. Whenever you are dealing with parameters passed by reference, you must ensure you are decomposing the problem and rigorously testing your assumptions. We are going to do a quick interactive workshop right now. Challenge number 1, the data scan. Imagine a highly complex data table on your screen right now, tracking a variable passed by reference through a nested loop. The clock is ticking, you have 60 seconds. What is the core trend you need to extract? The trend you should be aggressively hunting for is that the global variable state is changing every single time the local procedure modifies it. If you miss that, the whole trace table falls apart. All right, moving to challenge number 2, find the flaw. I'm going to read a sample paragraph submitted by a student, and you have to spot exactly where they lose their marks. Listen closely. The procedure takes the customer array by reference, meaning it makes a local copy to manipulate, which saves overall processing time. Did you catch it? The fatal flaw is the phrase, makes a local copy. Passing by reference absolutely, unequivocally, does not make a copy. It points directly to the original memory address. A Cambridge examiner would immediately strike a red line through that entire sentence, and there goes your A-star.
This brilliantly illustrates how critical analysis actually works in these exams. You must explicitly compare both the similarities and the differences of alternative approaches. Let's do our third challenge, speed writing. You have 30 seconds on the clock to mentally draft one perfect Peel paragraph comparing pass by reference to pass by value. Go. Think about your point. Think about your evidence from the syllabus. Explain the exact difference in memory handling at the hardware level, and link it to algorithm efficiency. Time's up. If your paragraph used comparative connectives like whereas or conversely, and explicitly stated that reference uses original memory while value allocates new memory space, you just secured top marks. That is the weightlifter strategy in action.
Which brings us to our final section, Section 4, Examiner Warnings and Insights. If you want top marks, you absolutely must apply your technical knowledge to the specific context of the question, and you must always check those edge cases. This right here is exactly where our rusher Sam loses all their marks. Rushing naturally leads to vague, generalized answers. If the exam question is specifically about a banking system updating an account balance via a procedure, you cannot just write, "the variable is updated." That is way too vague. You must write, "the account balance parameter is passed by reference," allowing the procedure to permanently deduct the withdrawal amount from that specific customer's database record. Context is king. Furthermore, failing to check boundary conditions, like what mathematically happens if the procedure tries to pass an empty string, a null value, or negative number by reference, will cost you heavily. You need to employ a time management matrix in the exam room. Allocate specific chunks of time to decoding the question, drafting your logic, and then explicitly checking your work against the provided scenario.
This brings us to the ultimate safety net for any computer science student, the method mark strategy. This strategy specifically rewards your systematic processing, even if the final result is flawed. When you are performing a complex trace or writing out lines of pseudocode, do not try to be a hero and do it all in your head. Write down the intermediate states. Show the memory address mappings in the margins if it helps you track the data flow. If you make a tiny, silly arithmetic error on line 4 of a massive 10-line trace table, but your underlying logic for handling the pass-by-reference parameter was entirely correct based on that flawed number, a good examiner can and will award you follow-through method marks. But hear me on this. They can only award marks for the ink they can actually see on the page. Invisible Genius scores 0.
I want you to remember this alert, burn it into your brain every single time you sit down to an exam paper. Process matters just as much as the final output. This isn't just about getting the final binary sequence or integer output correct. It's about systematically proving to the examiner that you possess the rigorous algorithmic thinking required of a true Cambridge computer scientist. By combining command word decoding, strict Peel framework application, and our time management matrix, you absolutely guarantee that your thought process is visible, highly logical, and heavily rewardable.
So, as you prepare for your next paper, you need to ask yourself, will you let a minor calculation error cost you the grade? Or will you use clear methodology to secure every possible mark? Are you going to be an Alex, aimlessly dumping facts without any context? A Sam, rushing and completely missing the point of the command words? Or are you going to step up and use the weightlifter strategy, applying targeted, explosive effort exactly where the grading rubric demands it? Students who actively implement these exact computer science strategies see an average improvement of 2 full grade boundaries. But that only happens if they practice consistently with our weekly videos. Here is your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Also, drop a comment below with your exact target grade for computer science and the biggest technical challenge you're currently facing. Our team responds to every single comment. Like this video and share it with your study partner so you can hold each other accountable. Ace the Exams. Your Cambridge success starts here.